Hey YouTube, what's up, Zeslink? Welcome back to another episode of Coding Session. Now, this isn't a problem that appeared in my weekly email from Leetcode, which is called the Leetcode Weekly Digest. I chose this problem because a couple episodes ago I went over the set data structure, and now I want to go over the list data structure with you guys. And I picked this problem because not just that it's a easy difficulty problem, but it's a very straightforward problem to where I can implement the list data structure in a very clear way when we're implementing our algorithm to solve this problem. So the list data structure is pretty straightforward. I'll walk you guys through it. And let's first start by reading the actual problem. So this is the single number problem. Given a non-empty array of integers, every element appears twice except for one. Find that single one. So I showed this document back in my set video, and to kind of review, a set is a list of elements uh, and no specific order, but there are no duplicate elements in the set. Every element in a set is unique, and you cannot add more than one specific elements. For example, I add 1, 2, 3 to my set, and I want to add 2. I can't do that because 2 is already in that set. So a set is a list of elements in no given specific order, and each element is unique. No duplicates are allowed in a set. While versus a list is a list of elements, no particular order, no specified order, but duplicate elements are allowed. And that's the pretty much the key differences between a list and a set. Set, only unique elements. List, duplicate elements are allowed. So in a set, of course, no duplicate elements are allowed. So there are many methods in the list data structure in the Java collections class, and this is very similar to other frameworks such as .NET. We have, for example, get, which we pass through. That's not what I wanted. Pass through a integer to get a specified element at the specified index of the list. We have contains, so we can pass through whatever of object type the list is and go ahead and see if it's actually in the list itself. We have add, you want to add an element to the list, and remove element of the list, or contains all. These are pretty much the more common methods in the list itself. So let's go ahead and develop our algorithm for this problem. So we're going to want to go ahead and implement the list data structure. We want to go through every single integer in the integer array nums and utilize the list data structure in a way to where we can detect or figure out the integer that is not duplicating. How do we do that? So let's start off by creating our list object reference. So list of type integer, no dupes, is equal to new array list. And if you watched episode 7, which was my object-oriented programming concepts video, you can clearly see we're using polymorphism here. We go back to that document. The list is the interface, and the array list is a subclass that implements the list interface. And of course you got the linked list and the vector, and then the vector itself, while it's a subclass that implements the list interface. The stack is a subclass that extends to the or extends from the vector class. So yeah, this is a very useful document that I got from my data structures class. And we're gonna want to go through the the integer array nums. So for this is an enhanced for loop for int I in nums, and you can kind of reread this as for each int I in nums, but Java does it differently. It's just a for and then whatever, the type int I and then colon and then the actual array itself, nums. And we're going to want to put some conditions here. So I'm going to negate this condition. So if no dupes that contains I, we're going to want to add the integer to our list here. So if the integer we're currently at in our integer array nums is not in our list, we want to add it to our list. Else we want to remove that element, and you're going to see why. So remove, and of course we specified the type of list, which is integer, so new integer and I. So pretty much just removing that integer from the list. And of course outside our for loop we need to return something, an int. So we're going to return no dupes 0, which is the first element of the list. Now you're probably asking why. Let me walk you through this. We're going through the entire integer array nums for each int I in nums. If the integer is not in our list, if our list does not contain this integer, we want to add that integer to our list. If it is in the list, we want to simply remove it. And of course, we simply return just the first element of the list. Why? Well, if we look at these examples here, we add 2 to our list because it's not in our list. Oh, but 2, and the next time the for loop executes, 2 is in our list. So this condition's false, and then whatever is in our else code block is going to run, which is going to remove the 2. So it removes the 2, and of course 1's not in our list, so we add 1, and of course what's the first element of our list? The integer that wasn't repeated, which is 1. Example 2. So 4 is not in our list, we add 4, second time the for loop runs. 1 is not in our list, added to our list. 2 is not in our list, added to the list. 1 is in our list. We don't add it, we then remove it, which is removing this one here. Now we go to 2. 2 is in our list. Don't add 2, we remove 2, which is removing this 2. And what is the last integer in our list at the first position, which is 4, which is the non-duplicating or repeating integer. So I should mention, when you're adding and removing, of course, when you're adding to a list, you're adding to the end of the list. But when you're removing an element to the list, it finds that element in such specified position, removes it, and reorders the list, array list, etc. In a respective way. So no matter what order, let's just I'll do an example. 1 1 2 3. We'll go 1 1 2 3. I'm sorry. 1 1. I'm sorry. I'm trying to think of a good example. I apologize. Okay. 1 1 2 3 3. We add 1. 1 is in our list. Remove it. 2. We add 2 is not in our list. We add 2. 3 is not in our list. We add 3. 3 is in our list. Remove 3. What's the remaining integer in the first position? 2. So that's a basic example of that. Let's run our code. Compile error. Oops, I forgot. I did went over it. The get method. Pass through an integer, which is an index, and at the specified index returns that element. You want to put .get. Run. All right, first test case passed. What about the other test cases? There we go. So we've solved the single number problem with our own algorithm implementing the list data structure. So I wanted to go over the list data structure because I've already went over set. So this is why I'm making this video and chose this problem to go ahead and go over the list data structure. It's very straightforward, very easy, very intuitive, and both the set and the list data structures, both of them are useful in their own unique ways and can be utilized on all sorts of specific problems. So that is the list data structure. Thank you guys for watching. I hope I explained it pretty well. If you want me to clear anything up, leave a comment down below and I gladly will. Thank you guys for watching and have a nice day.